Maybe I can just
Yeah.
okay. So we're starting with the very first part. Okay. The system architect. Just 1 second. Let me just resume. So system architect is our first topic that we're discussing. Okay. Now, computer systems, whenever we talk about obviously computer systems, we tend to mean about uh, a system. Basically, I told you before, it consists of hardware, software, user, and procedure. So the essential purpose of the system obviously is over here is that it has to take in the data, it has to store the data, it has to process the data, and has to output the data. Okay, right? Obviously, this is why we have systems. Computers are made up of hardware, software working together. But if you elaborate this, I told you you need to add two more things, which is obviously is the user, and you have to add is the procedure as well. Now, procedure means how you're supposed to use it, and user obviously is the one using this. Hardware, obviously, what hardware, CPU, monitor, motherboard, something very basic. Okay. And softwares are programs, are set of codes that will instruct the system what has to do. If we start discussing in detail, well, obviously we have discussed this before, there's no issue. We do know that what an OS is, and we do know there are different kinds. There's command line interface, there is a GUI. We know all that. Okay. There's also
Yeah.
basically a menu driven as well, if we go in much more detail. But that's not our topic right now, so I'm not sticking to that. Okay, because
Yeah.
since we're doing topic, so I'll stick to that. I don't want to go here and there. Um, so
From my
basically,
room.
what we
Wait,
have over
so I
here
wanna,
is
let me
we
keep my
have.
brother out.
Okay, so should I continue?
Yeah, let me keep my brother out of the room just a
Okay,
few minutes.
right. So obviously, I mean, since middle school, you know this input consists of keyboard and mouse. Input is basically given to the processor, which is the CPU, central processing unit, that will process everything. Then also you have GPU. GPU basically is the graphic processing unit. A graphic processing unit is there to work with high resolution. So whenever you have is high resolution to be worked with, we need to have more GPU, especially in games. Okay, so the NVIDIA graphic cards that you have, this is handled by a GPU. Okay, so nowadays when you buy laptop computers, they have to have a good CPU and a good GPU as well. Primary storage, we know that we have RAM and ROM. RAM basically tends to be
Random access
volatile,
memory.
which means the storage will disappear as long as power is being supplied. If the power is not being supplied, obviously the data will be lost. ROM, read-only memory, your manufacturer details are fed into the ROM. In a computer motherboard, it's also known as the BIOS, the binary input output system. Okay, it's from the ROM that when you boot in something, all the instructions come in, and this is how the peripheral devices are checked in, and this is how the instructions are given in, that you have to fetch the data from the hard drive and load the os.exe file, and this is where Windows gets boots up. Okay, well, in short, primary storage is that storage that is used in the initial booting process of an operating system, okay, of a computer. Secondary storage, that is used to store data permanently. Why do we use the permanently? By permanently, we don't mean that it can be erased. It can be erased, which means it's non-volatile. So hard disk drive, solid
What's
state.
the difference between non-volatile and volatile?
Volatile means it will erase. So for example, if I copy something, okay, and I'm going to paste it somewhere, and suddenly
Mm.
my computer turns off. So when you start your computer again, will you be able to paste again? No, because while you copied, it went into the clipboard. Okay, so your RAM basically is where the data goes into clipboard. And you know what a clipboard is? Okay, it's a temporary
Yep.
space where data is fed in. But if you turn it off, if the electric current is not being supplied to it, obviously this will disappear. So volatile means that it's temporary. It's there as long as the computer is on. Non-volatile means secondary storage. Secondary storage where data will be permanently stored. Okay, a memory stick, an SD card, in a solid state, and hard disk drive. You leave it for a month, 2 months, a year. You open it again, you can get the data again. Okay, And so all the permanent data needs to be in the secondary. Okay. And all the temporary data goes into your primary storage, right? Particularly in your RAM. Output obviously happens with the help of monitor, printer, and speaker. When we talk about output, obviously we're talking about digital to analog conversion, and obviously you know that. And when we talk about input, we're talking about analog to digital conversion. So we have DAC and we have ADC at the same time. Yeah, the reason why I went a bit fast was because obviously this is something that we have done before. So I'm pretty sure there's no problem in this part.
Yes, no.
Yeah, exactly. Because I know you by now, that's why. Okay, but wherever you feel to find, I'm not getting this. Ayan, please stop me, because now what we do, we have to make sure we're 100% clear on everything. You get my point?
Yes.
Okay, because we are obviously right. Yeah, it has to be excellent. The general purpose systems, computer systems that perform many tasks. Your laptops nowadays that do multitasking, that consist of your general purpose. They're multitasking computers. Okay. Dedicated systems, actually, as far as dedicated systems are concerned, we also call them is an phenomenon you have is a dedicated microprocessor in your air conditioning system. You can input a particular value inside that. So, I mean, dedicated systems just do one particular task. Maybe in a satellite TV receiver, or maybe in a fridge, or maybe in a microwave oven. So you have is a one small processor that will be doing one particular task. Embedded systems are built into other devices. Okay. Another example, maybe they're embedded into a home security system, maybe in a hospital intelligence system. So, I mean, these computer systems could be used in general purpose, could be dedicated systems, could be embedded systems. I mean, computers could be used anywhere. But general purpose is where we talk about multitasking. Okay, these require the most of the resources. These are not very powerful. This is also not very powerful, because both of these will be doing a specific task, nothing more than that. Okay, types of embedded system, very important. I just told you that embedded systems, we can talk about washing machines, dishwashers, microwaves, oven, your air conditioning systems. These devices are not primarily intended to process data, but to perform other tasks instead. For example, to compare, we have always talked about it, the preset value has to compare it with the actual value. Now, what is the preset value and what's the actual value? Let's talk about this a bit more. We have actually talked about this more, actually. Let's say in your washing machine, you have is a pressure sensor. And the pressure sensor says that the maximum load that you can put inside the washing machine is, let's say, 10 pounds. Okay, I'll speak your units, not kilograms. So you can put 10 pounds. So what happens is
we use kilograms in the England.
Exactly, it's 10 pounds also fine. So if I exceed more than 10 pounds, I have actually a sensor that will tell me the buzzer that you just turn on the beep or the buzzer. You can't exceed that, because that might damage the machinery inside it. Or in an air conditioning system, we set the temperature of the air conditioning system to be, let's say, 20 degrees Celsius. And the actual temperature right now is 30 degrees Celsius. So this is the preset value. That's the actual value. Once the preset value is not equal to the actual value, the output compressor, the machinery, will keep on cooling the room. Now, why am I talking about all this? Why am I talking? Because I'm trying to tell you is that the preset value is actually fed in by the user. And this is fed in into the embedded system. Okay. So we can embed every time. We can tell what the system what to do. Now, this preset value and actual value could be used for dishwashers, washing machines, micro ovens. We can always set these values. You get my point?
Yeah.
Yeah, right. The purpose of embedded system obviously is to monitor and control various components. I just told you the example that I was giving you. So it will monitor and control It will keep on monitoring, and if it exceeds, it will obviously stop it, right? So this is what embedded systems would do. You can take out any example. This is how embedded systems work. For example, if we talk about, let's say, embedded system in a traffic control system, or even in a car security system, this is the way that it will work. Okay. Benefits, obviously, there are lots of benefits of embedded computer systems. First of all, nowadays they're cheap to produce and they consume a lot less power. They're very much reliable nowadays, frankly speaking. Okay, they're only designed for the purpose task. The software cannot be easily to be updated once manufacturer has fed into it. This could also be a disadvantage of it. Their composite relatively simple compared to those dedicated. So that's what it is. CPU, central processing unit. You know what a processor is. You have pins over here as well. Okay, and now a CPU basically consists of different parts. We'll talk about that. It's there to process instructions that are input or that are stored within the devices. CPU does this by manipulating the flow of electricity through billions of electrically operated switches called transistors. We were going to talk about transistors, logic gates, but then we started the revision. Very soon we'll be coming there. Very interesting topic. We'll talk about all the logic gates that are combined together to make up the transistors. And why do we need the transistors? We need the transistors. Why? Because we want to control the flow of electric current going here and there, just like taps, just like traffic policemen controlling the traffic, or traffic lights controlling how much traffic at what time should go. Okay, so CPU basically is on the motherboard. It's connected through buses, okay, and connected to RAM and the hard drive as well. Okay, which obviously you know what buses actually are. We did talk about it before. I did tell you that that's your motherboard, and through buses, you have buses that, let's say, that's your CPU. That's your CPU.
Yeah.
You connect to your RAM, you connect to your hard drive, they connect to other components. So it's through buses called these copper wires that you connect. Von Neumann CPU architecture basically was invented in 1945. That actually meant was that the three parts of the computer system, of the CPU. Okay, since then, we know that a CPU consists of control unit that is there to control all the data where it has to go, where it's coming. It has the arithmetic logic unit. It will be doing what? Arithmetic logic unit will be controlling all the comparison operations that you have, which could include less than, greater than, less than, equal to, greater than, equal to, okay, or equal to, all these comparisons. Okay, your ALU will do plus, minus, division, multiplication, modulus, whatever. Obviously, ALU will be doing that. Now, all these calculations, all these are happening, and they will be stored in a register. A register is also known as a cache. Okay, a cache basically, or a cache. I mean, I don't know how you pronounce it, but cache is a temporary space that you have within processors. Okay, that can store data. The more cache you have, the more better processing will happen. Okay, so this is why we have registers built in within the processor. So three parts that we have. Any problem?
No.
No, exactly. You know this. So I just talked about it. We have obviously a control unit that has a clock. Okay, a decoder. That's the two parts of its control unit. ALU. Then we have different kinds of registers. We have memory address register that holds the memory location of the registers, memory data register, accumulator. We'll talk about all these program counters in detail. And then they go in and out to basically the primary storage, which is the RAM and the ROM. So that's what your CPU that does consist of. Okay. Now, as far as your control unit is concerned, it's there to execute instructions and send control signals to other components. Obviously, this is what it does. It sends all these instructions. a control unit will be there, and the decoder and the clock are two parts of the control unit, the decoder and the clock. The clock basically is there to synchronize all the activities. Clock tells you what to do at what time to do. Okay, so this time management of the data, all this synchronization of the activities that are being done between components and the CPU is basically done through the clock. So clock tells it. Okay, right? So obviously, you open up different programs, and first come first serve basis. You have to see how much time should be given to what program. The clock will be doing all this. A decoder obviously is there to decode the instructions and retrieve them from the memory. So when we talk about the fetch execute cycle, it's the decoder that decodes, fetches it, decodes it, and then executes it. You fetch the data, you decode it, and you execute it. So obviously, this all time management and the coding has to be done with the clock and the decoder. And these two obviously simultaneously, they work together. And that's how the CU technically works. Yes or no? Okay. A good example of this would be that you have is a computerized traffic control system in a traffic, and over there, obviously, the clock timer will tell how much time is left and how much cars have to pass by. And a decoder basically will be there finding out how many cars are there in a junction and doing all these calculations. It's just the same example that you have. Okay, then you have the arithmetic logic unit, the second part. Obviously, I told you before, these two. I just told you that, okay? Then we have obviously is the registers, where we have the MAR, which is the memory address register, one of the very important register that you have. Okay, this memory address register holds the address of the location in the memory. Okay, holds the address of the location in the memory where data or instruction is to be retrieved or stored. So as per its name, obviously you will never forget that it holds the address of the location in the memory. Very simple. Memory data register holds the data. So memory data register, it actually holds the data, not the address. Okay, so holds the data or the instructions. For example, LDR, that you're supposed to load something, that's an instruction. So, or maybe it might have 50. That's the data. So it will hold either 50 or it will either hold LDR, which is an instruction. Okay, that has to be retrieved. Okay, then we have an accumulator. Accumulator obviously holds the result of calculations. Okay, so whatever calculation I've done 5 plus 1. Okay, this actually will go where? It will go into a register. That is the accumulator. So accumulator is directly connected with the arithmetic logic unit. You see, these results can be fed back into the ALU for you. So ALU is working along with the accumulator.
Was the ALU?
Arithmetic logic unit.
Okay.
Okay, you get the point. So we're actually talking about registers. There are different registers. Registers are temporary places. Just think about registers as a notebook, as physical notebooks that you have. A memory address register is where you have a note of all the addresses of the locations. You have MDR that holds the data or the instructions that have been retrieved from the memory. Okay, what data was there? What instruction was there? Okay, your accumulator holds the result of the calculation. You just did some calculation, it has to be stored somewhere. This temporary place where it's being stored, all these calculations go inside the accumulator. Program counter, you use a loop. Okay, so obviously a program counter will be there to hold the next instruction to be performed. Obviously, the CPU has to keep on performing these processes one after the other. These processes have to be incremented every time. These processes have to be fetched. they have to be executed. This has to keep on going on. Now, how does this keep on going on? There has to be a program counter. There has to be a way that I keep on saying, okay, n plus 1, okay? Next instruction comes in, 5, 6, 7. So program counter keeps on counting how many instruction I'm doing. Why do I have to do that? First of all, because I have to keep a record that every instruction has been met. Secondly, if there has been some issue, okay, that can be addressed, a log of that problem can be made, and maybe it could be given to the user, or maybe the operating system can recover it. Anyway, that's an advanced topic. I don't want to get into that. But in simple, program counter holds the memory location address of the next instruction. That's it. Okay. Whatever next instruction has to come in, it will hold its memory address location. So these are just 4 basic that we have that you're supposed to know. Okay. Now the way we will be doing, Ayan, would be, I would like every time when we do it, I would verbally just take a test. No, it's not test. I'll just question you next time. In fact, if you want, I can share this PDF file with you or whatever, the same. And I'll ask you randomly any questions, because I just want you to revise everything. Yeah, we'll do it this way every time. Okay. So it's beneficial for you as well. Okay. Yeah, it's more important that we study with a smart plan rather than just keep on studying for hours and hours. Okay, obviously you know that. I mean, so some people just study for 2 hours and they get an A-star distinction, and some people keep on studying for 10 hours and still they can't cope up. Why? Because probably they are not focusing the way they should be doing. That's what I keep on telling my students. It's how focused you are. Okay, and that's the most important thing, focusing. If I'm studying, I would just study. I will not look at my phone. I'll not be talking to my friends. I would not be going on social media. I think so I should be doing what I have to do. Okay, anyway. Okay, well, not doing a motivational speak over here. So anyway, in order to process instructions, the CPU needs to retrieve. Okay, so processing from memory, I talked about fetch, decode, execute cycle. Cycle repeats billions of times each second. So we just talked about this, right? Right. So a fetch execute cycle obviously does is that it would fetch instructions from the main memory. Okay, and obviously the program counter is there to register all of that. A program counter will be incrementing. The fetched instruction is decoded by the control unit. The CPU executes the instructions by performing the appropriate operation. For example, the ALU might perform a calculation, or data might be loaded from memory. The cycle repeats until halt instruction is retrieved. So this means obviously this keeps on going. But halt instruction basically means what? What do you think? The 5th point means what?
The cycle repeats itself until it gets to the answer it wants to be.
Yeah, halt means what? Halt means stop it.
Stop.
Yeah, I mean, this instruction doesn't have to continue any further. So we'll halt it. Right? So obviously halt instruction we'll stop it over there. Fetch execute cycle actually means what? Now let's discuss this, which is important. Now, fetch, execute, and decode. Fetch means the address of the next instruction to be processed is copied from the program counter to the memory address register. Okay, right? So we copy it from the program counter to the memory address. The PC, the program counter, is incremented to a point to the next instruction that will be needed when the cycle starts again. The instruction stored at the location held by the memory register is copied to the MDR, okay, where your data is stored. So in fetch, we are talking about the program counter as well. In the fetch, we are also talking about the memory address register, and the fetch, we're also talking about the MDR. So we have to mention that, obviously, because if you fetch something, you have to tell, okay, this is the first data I have fetched, okay? And then the program counter will say the second one will be fetched, or third one. But at the same time, you're fetching this data from a particular address. So in fetch, MAR is playing its role as well. At the same time, these instructions that are being fetched, obviously they are stored by MAR, but they copied to the MDR, memory data register. Okay, so the address to the data. MAR has the address, MDR has the data. So you have to get the data from MDR, and MAR gets the data, and program counter does its job at the same time. Do you get the point? How are we relating your PC, MAR, and MDR? No, be sure. Be sure. Are you sure?
Yeah.
Okay, right? So we have to remember that in fetch, whenever you get the question of fetch, remember we're talking about PC, we're talking about MAR, and we're talking about MDR. Okay.
Yeah.
Okay. What is execute? Okay, let's talk about execute. So yeah, execute, exactly. To execute, basically perform the appropriate.
To perform the operation, what to do? Basically, when it gets it, it operates like it does it.
Sorry.
The execute part is not when the basically everything execute, like when it starts, like everything goes into place.
Exactly. Execute, yeah. So obviously, every command, when we say it has to be executed, it actually means that it will be performed. Okay. In fact, let me talk about decode. So decode, actually, let's start, continue with decode. So fetch, I'm sorry, from fetch, I should have gone to decode. The control unit decodes the instructions and sends control signals to the component within. So decode obviously would be converting into a form that the CPUs can perform. And then after that, we have is execute. After decoded, it has to be performed. The ALU will do its job. The value of stored by the program counter or memory register might be changed. So in execution, we are obviously incrementing the program counter. We were changing the memory address register as well. So that's the way all the cycle goes on. We fetch, we decode, and we execute. So execution just means to perform. We're performing it in simple words. We're performing all the instructions that will be done by the ALU. Okay, we'll be executing the program counter, which means what the value stored in the memory address register will be executed. Okay, or in simple word, executed means it will be displayed, performed, done. You get my point?
Yep.
Right? Understanding program. Okay. Now there are two codes. Program instructions that we have. This is very interesting. For example, it could be this and this. Okay, there are two parts. One is the opcode and one is operand. Opcodes are the first part of the instruction, and they can determine what the operation CPU might perform. Okay, so opcode are actually operations. The second part of the instruction, and they are so operands basically a second part. Okay, did this include what? The values needed for operation. For example, they might represent a memory location for a save data operation, or they may represent a number to include addition. Let me give you an example over here. Look over here. Now, this is actually what we have. We have over here is this. The first part of the instruction is an opcode. That's an opcode. Okay. The second part of the instruction is an operand. So that's an operand. Okay. Right. So add, we will basically do what? Instruction add adds the value of the accumulator to the value. So maybe you want to add, you want to store, you want to delete, you want to stop. These are all my instructions that I'm giving. Okay.
Yep.
So you have two parts. Okay. Factors affecting the CPU performance, obviously the clock speed of CPU, the number of cores that you have in CPU, which is also known as the threading.
So the more amount of cores you have, the higher the speed of the CPU.
Exactly. Yes. I mean, like a decade back, quad core came in. Okay, then octa core came in. So obviously, quad core where you had four processors within one processor. And this is where we said that the computers can do multiple tasks at the same time. Okay, then octa-core came in, and obviously this kept on growing. The amount of cache memory, that's very important. Cache memory basically is the memory that you have inside the processor. So this cache memory that you have, if this is bigger, obviously your fetch execute cycle that we were just talking about again and again, this could be done a lot more because I could get more data fetched in, execute it, decode it, execute, decode it. So this could go really faster. So if your cache memory is small, if you let's say if you have a very small table, you could just put small little things on there, not too many things. But you have a bigger table, you could put lots of things, and someone could carry them, process them, and forward them. So cache memory is very important for more data to be processed. Okay.
Yeah, you know the cores is like Intel Core 7.
Sorry.
Like you know the cores you say like Intel Core 7.
Exactly. Yes. Intel Core 7 and all that. Exactly. Yes.
Yeah. Also, your question. Do you in Pakistan, right? Is it true that when you go to like the border, you have a new iPhone, they put in like some type of computer virus into it or system?
Yes. Yes, it's true.
Oh, but
But
you is that it's not an embedded system, is it?
yes, exactly.
Yeah, is it also can you they use the not IP address, the MAC address to track where you are?
Uh, I mean, it depends actually. It depends actually.
Doesn't
I
make
don't know
sense.
which reference you're saying that.
My uncle, my
Uh-huh.
mom, he basically goes to Dubai very often, like every month. Every time he comes with a new phone, they always put something on it.
Okay.
Apparently, to like keep control of your phone or know what you're doing on it.
Right.
Yeah.
Okay. Okay. Right. 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 Who does it? Is your friend?
No, my mom, my uncle, my mom's sister,
Yeah. Yeah. Okay.
my
Yeah.
mom's brother, sorry.
Okay. Okay. Right.
Yeah.
Right. Right.
But
Right.
how are they able to add it if it's not an embedded system?
Is he sort of like an engineer or someone?
No, he just has he's an accountant.
Oh, still good. Okay.
So he's got his own business and he works for a company.
Okay.
So yeah, they say they always put something. But yeah, because that's yeah, they put something, a computer software onto a phone. It's not an embedded system. So how do you place it into it to make sure it stays?
Okay. Right. 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 In fact, you know what? I was forget now. I'll start sharing some very important videos with you. That would explain all this in more detail. I mean, the really good one. Okay, not those nasty videos or that. I will keep on doing that. So whenever you have time, just short one. Okay, because with animation, probably we can learn more about this.
Where do I find the video?
I'll share with you.
Is it on your website?
No. I'll share you on WhatsApp. Is it fine?
Oh, oh yeah, okay.
Okay, I'll share you on WhatsApp.
Yeah, your website, LGS, my mom went there.
Yeah, I'm updating my website. In let's say 10 days time, I'll
Yeah.
get it will be updated, and there will be a lot more information over there.
Yeah,
So
no, my mom went to Lahore Grammar School.
you're what? So really?
My mom went to Lahore Grammar School.
Oh, she did.
Yeah, my mom, my brother, not my brother, my mom, my mom's brother and my uncle went there.
Oh, really? Well, what year?
Yeah,
What year? Which year?
oh, 1990 something, 1993 probably.
Okay. Right. Right.
Yeah,
Interesting, right?
yeah,
Okay.
they used to live in Gulberg back
Yeah, in
then.
group. Actually, I'm teaching this since 2002.
Okay, yeah.
Yeah, I'm teaching this from in Gulberg. I'm in the head office. I'm the head of IT over there.
Ah, school,
Yeah,
yeah.
and I teach.
During Gulberg, during Gulberg, there's a new flats coming, T Square.
Yes. There is.
T Square. My uncle owns it. My uncle's building it.
Okay. Right. Yes, so it's over there.
There
Yes.
used to be his house and the neighbor's house. They combined it together. So one part's already done. They're building the second T. It's like they make a T. T
Okay.
Square.
Okay, yeah. I've
Yeah,
seen it.
should be.
I've seen
Yeah,
the
it should
billboard.
be. Yeah, it should be done next year. That's when I'll come to see it. Be done next year for me, not for me, but it'll be done.
Okay. Are you coming over this time?
No, I was going to,
Mm-hmm.
but then we might go to America and Canada.
Okay, when?
This summer maybe, but probably next. No, not next year. 2 years, maybe a year or two. I'll come next year summer probably.
Okay. Right.
Next year summer I'll be back in Pakistan,
Right,
chilling.
right. Okay, then what I'll do is I'll just stop here because we can go slow. I mean, not very slow. We can obviously increase the speed next time. Okay.
Yep.
So I want you to revise till here next time. I'll just share this with you as well. Okay, right?
Mm-hmm.
Till page 27,